Hi everybody, so we've designed our digital circuit and we've sent it to the workshop to be manufactured. But how can we make sure that the circuit works properly? For every different combination of inputs, we need to know what the output should be. Then we will be able to test properly the actual physical digital circuit. So as we're planning our circuit, we need to create a truth table, and we need to determine for every combination of input what the output is. So with a digital circuit of 3 inputs, there should be 8 possible combinations of input, starting at 0, so 0, 0, 0. And finishing at 1, 1, 1. So starting at 0 and finishing at 7. And if you step through this, you'll see this is equivalent to 0, sorry. This is 0, 1, 2, 3, 4, 5, 6, 7. So your truth table should have the proper sequence to represent every possible combination of input. Now what I want in my output, which is here, the output of this OR gate is the result. What I want is X, not X and Y, or Y and Z. So I've got to try and calculate all of that so I can figure out the output. And my brain is not focused enough today to be able to do all of that complicated logic. So what I'm going to do, I'm going to break down the logic of this circuit into manageable steps. What I'm going to do, for each of these 3 gates here, I'm going to determine the output of each gate. That will help me to manage the development of the truth table. So the output of the NOT gate, I'm going to log the output. The output of this AND gate, I'm also going to log the output, which is here. And the output of this AND gate, I'm going to log the output as well. And that will help me to determine the final output of this gate. So let's just annotate on my diagram the output of the NOT gate. I'm just going to call that point number 1, or line number 1, up to you, what you call it. The line here, which is the output of the AND gate, and this line here, which is the output of the next AND gate. So I've got 3 points on my circuit. I'm now going to put these points into my truth table. Okay? Now, let's start to write down the output at these 3 points. So let's start with point 1. We can see that the output at point 1 is simply not X. Okay, so X is 0, it should be 1 here. X is 0, should be 1 here. 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0. Okay, so hopefully this is the correct list of outputs for every combination of X inputs in my truth table. Now let's go to point 2 on my diagram. This is the output of this AND gate. So now we can see that this is 1 and Y. Okay? 1 and Y is what we're going to see at point 2. So this and this. So 1 and 0, 1 and 0, 1 and 1, 1 and 1, 0 and 0, 0 and 0, 0 and 1, 0 and 1. So that's point 1 ANDed with the Y, which is the output here at point 2. So let's see what that looks like. Okay, 1 and 0 is 0, 1 and 0 is 0. 1 and 1 is 1, etc. Okay? Ooh, have I just made a mistake? I think I've made a mistake. Isn't that interesting? 1 and 1 is 1. 1 and 1 is 1. 0 and 0. Okay, I think it's okay. Yes, that's fine. Okay, let's go to step number 3, point 3 here, which is y and z. Y and z. So point 3 is y and z. So 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. So column 3 here, this column here on our truth table should look like this. Okay? Now, the output, now that we've broken all of this down, the output is simply 2 or 3. That's the output. 2, whatever's at 2, or with whatever's at 3. Well, we've just calculated what's at 2 and 3. We've done that all here. Here it is. So now we can do the final calculation here. 0 or 0 is 0. 0 or 0 is 0. 1 or 0 is 1. 1 or 1 is 1. 0 or 0 is 0. 0 or 0 is 0. 0 or 0 is 0. 0 or 1 is 1. And this should be the final output of this logic circuit. And here is the final truth table.